My name is Chikara Kakizawa. I am an applications engineer at OnSemiconductor for the Timing Solutions Group. Today we'll be talking about the OnSemiconductor OmniClock. It is a one-time programmable clock generator. For the demonstration, we have the OmniClock programming board and the evaluation kit. We have a frequency counter to measure the output, and we have the monitor for the computer, which has the accompanying software, Clock Cruiser, for all the programming needs. So this is the very first screen of the Clock Cruiser program. You see 4 devices in the OmniClock family that we are offering at the moment. We have a 3.3 volt device, we have a 1.8 volt device, a QFN16 device, and a DFN8 device. What we have in the evaluation board right now is the QFN16 device. So we'll highlight that and go to proceed. This is the block diagram for each of the devices. The second screen is where all the programming is done. Each device has 4 configurable settings. You can use one of these settings for each unique application, which makes it easy for you because if you qualify one part, then you can use it for multiple solutions. First, you'll want to see if you want to enable the configuration or not. You can also copy over the configuration tabs. So if 2 or 3 have very similar output requirements, then you don't have to type in everything all over again. For the input, the OmniClock accepts crystal or reference clock, anything between 2 megahertz to 200 megahertz. Today, for this evaluation, we have a 25 megahertz crystal that we'll be using. So we'll hit crystal. We'll leave the load capacitor, effective series resistance at the default setting. The input frequency for the crystal is 25. Spread spectrum. You have an option to do no spread, down spread, or center spread, each with various percentage. For example, minus 0.25 to minus 4%. But we'll do the no spread. The OmniClock has 3 output banks. Each can be configured individually. So you can use this for LV-CMOS single-ended, and you can have 3 of those. Or we can turn one of them into a differential pair, and you can see it grays out this one because it has to match the first channel. We also offer LVDS, HCSL, CML, so all the standard data types required in our industry. So for evaluation, we'll go to LV-CMOS. We will set the output frequency here. So by default, it is at 50, but let's say you want 10 megahertz for one of your lines, 50 megahertz maybe for your processor. And let's say you have a very unique application that requires something not found in standard devices. So we'll hit 180 megahertz, and we'll really make sure to lock onto that frequency. VDDO, 3.3, 2.5, or 1.8. So we'll keep each output at 3.3. Drive strength, anything between 16 to 4 in 4 milliamp increments. You could invert the output if that's something that your system requires, or you can bypass the PLL. Okay, the next step is to program the device. So we'll first hit the solve button. And what the Clock Cruiser program does is it takes all your settings from above and calculates the configuration based on your requirements. So you might care about the PPM of each output. You might care more about your device current or your phase jitter. Whatever it is, you'll select the one that meets your requirements. So I would like something with good jitter, and I don't care too much about the current strength. There are 16 different solutions that the program will generate. We'll put it into the programming mode by flipping a switch and disconnecting the output, and hit the program device button. The green light means that the evaluation board and the computer is making a good connection. As you can see, the evaluation board is running strictly off the USB supply. There's no external hardware required for evaluation other than the scope or the counter. So you can OTP the device, or you can write to the registers to test the function of the device before you make it permanent. And we'll do that today. and register write finished. So
now I switch, so basically exactly again.
first we'll monitor the first output. This one should be 10 megahertz as we just set. And you can see on the counter that it is exactly, well, very, very, very close to 10 megahertz. And okay, this one is set to 50 megahertz. We see it's at 49.999 is what the equipment is reading. And lastly, this is the unique one of 180 megahertz. And once again, we see a very accurate result on the frequency counter. The features and benefits of OmniClock, there are 4 huge advantages that we bring to you. First, it is extremely flexible. You can customize the configuration, including frequency, pinout, voltage, output type, and current drive, which is great because that fits many applications. It comes in a very small package. We offer QFN16 3x3mm or DFN8 2x2mm. The 16-pin option has individual output enable for applications that require deep power saving states. The small area saves board space, and you combine multiple crystal oscillators into one low-cost solution. OmniClock is very low power, and this is great because it extends your battery life, and you can use your portable consumer devices for a longer amount of time. And we offer spread spectrum capability for EMI reduction applications.